In this lesson, we're going to talk about circles, arcs, and sectors. So for a circle with a radius of r, as you see here, so here's our circle, radius of r. Circumference, 2 pi r. That's how I find the circumference. Remember, circumference is all the way around. That's our circumference. It's like the perimeter of a circle. Essentially, that's what it is. Area is pi r squared. I think those are uniform shape, but you should just know them anyway, because come on. Arc, the arc is just a part of the perimeter. So it's just like this part. That's the arc we want to find. And so how do you find that? Well, you take the perimeter, and you times it by what percentage of the arc you want. So theta over 360. So this is how we do in degrees. We'll learn how to do it in radians later, which is in your formula sheet, it's all in radians, but I'll give you this one first. A sector is a region between two radii in circles. So here's a sector, right? So you have a radius here and a radius there and an angle. This part inside the sector. And there's two things we could find with the sector. The first thing we can find is the perimeter of a sector. Now, perimeter is just what encloses that sector. So it's the radius plus the arc length. So that's what you see here. 2 radius plus arc length. Again, a lot of times I just put radius plus arc length. But same idea, right? You want to enclose the path. So radius plus arc length. That's how you find the perimeter. And if you want to find the area, it's all like to find the arc length. Right? To find the arc length, you get the whole circumference and then times it by only the part of it you want. What percentage of the circle you want. Same thing with area of the circle. You get the area of the whole circle, pi r squared, and then times it by only by the portion of the sector you want. So that portion over 360. So the full circle is 360. So there you go. Those are the 3 equations we're going to use in this lesson. We're going to use arc length, perimeter, and area. So let's do an example. So in this little slice here, for the given figure, to 3 sig figs, find the length of the arc. So arc length, right? So it's just the percentage over 360. What angle do I have over a full circle times by the circumference of a circle, 2 pi r. Well, my r is 3, and my angle is 48 degrees. So 48 over 360 times 2 pi r times 3. And whatever that turns out to be is my answer. I did it on the side here, so 3 sig figs at 2.51. So yeah, that's our arc length. B, let's find the perimeter of the circle now. Well, perimeter of the circle is the arc length, which right here is 2.51, plus this radius here, so that's me right. That's way too thick. There we go. Come on. So it's that side 3, plus that arc there, 2.57, plus this side, which is also 3. So it's me 3 plus 2.51. I could do that. That is 8.51 centimeters. Sorry. So there we go. Area of a sector. So it's much like doing the perimeter. It's the part of the sector you want. So theta over 360 times the area of a circle, pi r squared. So I get 48 over 360 times pi times 3 squared. I'm going to use my calculator again to do that because I don't know what that is. 48 divided by 360 times 3 squared pi. So 3.79. 7736 sig figs. So round to 7. So there we go. That's area of a sector, that's perimeter, and that's arc length. Let's do another one. I want to find the area of this thing. Well, I think they mean specifically the area of this portion right here. So that's area of a sector. We want whatever portion of that circle we want times pi r squared. Now my r is 9.2 squared. The portion of the circle I want, well, I know the full circle is 360, and this part outside is 100. So I get 360 minus 100 gets me 260. So that's what I want here. So 260 over 360 times 9.2 squared times pi. Put that all into my calculator. So it's 26 over 36, zeros canceled, times 9.2 squared times pi. I get 192. Well, 192 from 36, it's just 192 centimeters squared because it is area. So I get that. Okay, last one. X and Y are centers of a circle. Of circles containing 2 arcs A and B shown. So it's a little funky. So what we have is a half circle here. AXB, and I have a half circle goes to the outside. So if I was gonna like recreate it, it looks like this. And then it's like that. My best guess, but that should be like a half circle. So I'm gonna put a half circle there. And it's also where like this outer ring right there, that's gonna become important in a second. That's this guy. Okay, there's that one. And then we have this quarter circle. It's quarter, like it's 90 degrees. That's, remember, a full circle is 360. Half of it's 180, which would be this. And then half of that's 90. It's a quarter circle. So a fourth of the circle. So that looks like this. And then like that. There we go. So that's a 90 degrees. This is A, Y, B. And then this inner ring right there is this guy. So like that. So that's kind of the way it looks. I want the length of AX. AX is this guy. So how are we going to do that? Well, if you just look at the triangle itself, now I've done everything else. Let me superimpose that triangle. Like that. It's a 90-degree triangle. This is 16. AX is right there. This is B. Since it's a 90-degree triangle and it's a circle, the key thing is a circle, these things are isosceles because those are both radiuses. Since it's a circle, these are both the same because these have a radius and the radiuses are the same. So if this is 16, this is 16. So I could do a squared plus b squared equals c squared, or these are 16. And I'm trying to find c. But you can also notice, since it's an isosceles triangle, this angle here is 45 degrees, and this one's 45 degrees. So it's isosceles, which just makes this a 45-45-90 triangle. If you know 45-45-90 triangle should be 1-1 rad 2. So if this is 16, this whole thing from here to here is 16 rad 2. Which makes the little, which makes this little AX here half of that, or 8 rad 2. The little radius right there. So there's that one, right? So how to get that? I look at the triangle. It's an isosceles triangle because they're both radiuses. So that means they have to be the exact same measurement. So 16, 16. You could do a squared plus b squared equals c squared and solve for c. Or if you notice, hey, wait, 16, 16, it's a 45-degree triangle. It's a 45-45-90 triangle. So it's 1-1 rad 2 is the ratio. So I get that. Good old geometry. Anyway, so that makes the halfway, this radius, 8 rad 2. Now I want to find the perimeter of the shaded crescent. So I want to find the perimeter of this crescent here. So the way you find the perimeter is, remember, you just enclose it. So I just got to find these two arcs, and that'll be my perimeter, because that encloses a little sector there. So I got to find this blue arc and this orange arc. Now remember, arc length is a very specific formula, which is the perimeter of the circle, 2 pi r, times what portion of the circle you want, which is theta over 360. Since a full circle is 360, I just want the portion of it that I want. So that's my formula I'm using for both of these. So 2 pi r times, in this case, 180 over 360. This is half the circle, so my angle will be 180. So this is going to be reduced to 1/2. What is my radius, though? What is this? We just found it right here. Right? It's the same thing. It's 8 rad 2. So on this, I'm going to get 2 pi r. Well, 2 pi times r, which is 8 rad 2, times 180 over 360, which is 1/2. I can reduce these, and I get 8 pi rad 2. That's the length of this purple arc right there. So 8 pi rad 2 is the length of that arc. Now I gotta find the length of this arc and then add them up, and that'll be my perimeter. Well, the way you find the length of this arc is the exact same thing. 2 pi r times 180 over 360. Sorry, not 180. Theta over 360. In this case, my theta is 90 degrees. That's my angle there. And my r, it's the radius. Something we used earlier, it's 16. So I get 32 pi times 90 over 360. You can reduce that. It's 1/4. This is 1/4 of the circle. So 1/4 So I just get 8 pi. So the length of this arc is 8 pi. The length of this part 8 pi over 2. If I want to find the perimeter, I always do that. I add this length, this arc plus that arc. So I just add them up. There's nothing really you can do, just leave it. So it's 8 pi plus 8 pi, add 2. If I wanted to, I could factor out the 8 pi. If I want to make it a little prettier, but you don't need to do that. So either one of those is fine. So that's the perimeter. That's the first one, that's B. C wants me to find the area of this. Okay, so the area is a little funkier. Alright, I want the area of that thing. So I'm going to need to find area of a sector. Now when I find it, so let's see, let me copy it down. Let me bring this down there so we can talk about it. That's not what I want to duplicate. Let's erase that. Let me see if I can copy now. Okay, let's bring it all the way down here. So I want the area of that sector. So remember, I only want the area of the shaded portion. So how are we going to do that? Well, if you look at this, let's look at this portion right now. So what I'm going to do here is find the area of the full circle, the half circle there. Which is pi r squared times 1/2. It's half a circle. And I'm going to subtract off there's this little portion right there. The little white portion. Right, if I subtract off those two things, I get what I want, which is this portion. Right, so if I do the full little thing right here, which is half a circle, minus this little thing, which I gotta talk about in a second, you get this, which is what I want. So how do I find this? This part's easy. This was just half circle is what was the radius for that? Pi times, I believe the radius was 8 rad 2 squared times 1/2. Right 2 because that's what the measurement of this guy was, 8 rad 2 from the earlier problem. How do I take off this? That's the problem. Well, the only way we can actually get this little portion into a formula is area of a sector. Because this right there, all that, is the fourth of the circle. So if I do pi r squared times 1/4, I will get this whole thing. That's not a good drawing. There we go. So I get this whole thing. Right? That gets me the area of all of that. But I don't want the area of all that. I just want the area of this little white thing right there. So what I do here is subtract off the area of that triangle there. Which is what? Area of triangle is 1/2 base times height. If you do that, so on this little portion right there, you go, okay, I'm going to do this full thing. It's area of a sector. Or it's like a fourth of a circle, so 1/4 times area of a circle. Subtract off the triangle. Then I get the little white portion right here that I need. So then I just got to subtract this from that, and I get my answer. So in this case, my radius is this line there, which we know is 16. So it's going to be pi times 16 squared times 1/4 minus 1/2. Base times height in a triangle, the right angle always tells you the base and the height. So it doesn't matter which one's which. One of these is the base, one of these is the height. In our case, both parts of the circle, the radiuses, so they're both 16. So it's times 16 times 16. So I get all that. Let's see. I'm just gonna put that. I guess I'll just put that on our calculator. There we go. So I'm gonna get pi times 16 squared times 1/4 minus 1/2 times 16 or 16 squared. And I get 73.069. So 73.1. So all this is 73.1, which is what this is. Right, so I got the area of the full circle here, or the quarter circle there, and I subtract off the area of the triangle. So I can only left this little portion right there. And that's 73.1. Now I want to figure out the area of this whole half circle, which is this right there. I subtract off the little portion I just found, then I get the shaded region. So I'm going to put this in our calculator. let's see, it's pi times 8 rad 2 squared times 1/2. 201, 3 sig figs, let's say about 201. Then we subtract off the 73.1 and we get our final answer. 127.96, 3 sig figs, about 128. And there we go.